Good morning, pre-calculus students. Welcome to another week, and we're getting ready here to start winding things down. We only have 3 more sections to look at, and then we're pretty much just reviewing and having our last test. So, yeah, we're kind of entering the home stretch here. Well, today let's go ahead and let's look at 10.3, which is numerical statistics. So we looked at a graphical look at statistics in 10.2. Now we're going to look more at a numerical analytical approach with formulas and analysis of that nature here in 10.3. For this, I would recommend that you get your calculators out and you have those with you because we are going to be doing a number of things with them as we look at 10.3. So let's go ahead and let's start looking at this. So first, we're going to begin with the concept of average. So average is one of those things that can have a number of meanings. If I was to ask you, what do you think of when you think of average? I usually do this in class and I give students a chance to respond. Unfortunately, now I can't sit here and hear your responses. But usually, students will say things like normal or middle or usual or ordinary. All these things become the concept of what we think of as average. But when we say, okay, what's average when we look at a bunch of numerical values, we have to figure out how is it we're actually going to calculate something that indicates those concepts. And what we find is there's enough of a difference in those concepts that we need multiple ways of determining what we think of as average. So we have multiple ways of determining what we call average, and so we're going to look at those. The first that we have is the mean. This is the one that oftentimes when you very first learn about average, they just say this is the average, but it's really one measure of average. And so what we do in the mean is we go ahead and we have the total value divided by the number of values. So we add up all of our different numerical values and then divide by the number of individual values that we have. So that's our classic way of determining average. It's got some strengths, it's got some weaknesses, and we'll talk about those. Our next one is the median. And as the name implies, the other place where we see median a lot of times in, we just see it in ordinary conversation, is it's the divider in the middle of the road. And that's what the median is. It's the middle. So what we see here is it's the middle number when we place all of our values in order. So when we place all of our values, we list them from lowest to highest or highest to lowest. We go and pick out the middle one. That is the median. So it's the middle. And it's got some strengths and it's got some weaknesses. So our final measure of average is the mode. And it's the most frequently occurring value. So if we take a look at all of our values, we see which one occurs most frequently. Then we have our mode. And that becomes another way of determining average, and it can be a very good one in certain circumstances, and it can be a very poor one in other circumstances. So all of these have real strengths and weaknesses. Oftentimes it's nice to know all 3 of them in order to really get a picture of average, but it's important to know when someone says the average is, how are they computing that? So you can recognize what possible weaknesses it has and what possible strengths. Okay, so example. Let's look at this set of test scores. So these are test scores that students got on a test, and I've listed them out there, and there's actually 8 results there on that one. And so this is just a hypothetical situation, but this is a good example to see some of the strengths and weaknesses of each one of these measures of average. So the first thing we're going to look at is we're going to look at the mean. And if we look at the mean, if we take all those values and we add them up, what we will get is, and then divide by 8, because there's 8 of those values, we get an average or a mean of 78.25. So now, interesting thing about that, when we look at that mean, when we go ahead and do that, is the mean is a C+. So in some cases, we could say, in some ways, that's a real good measure of, notice grades stretch from A to F. So in some ways, maybe a C plus is a good measure of that. But it is kind of weird. Our average score, how many students got a C plus? None. How many students even got a C? None. So in one sense, that could be a good measure, but in another sense, it's really odd to say, obviously that's not an ordinary, and when we say an average score, it's not an ordinary score at all. It's not a common score. No one got it. So in some senses, you could say that's a horrible measure of average when not anyone even got a C. So the mean has some strength and it has some weaknesses in that regards. Okay, well, let's look at our median. Well, if we look at our median, we do have a problem. If I look for the middle number, there is no number in the middle. There's 8 numbers. So what do? Well, what I do is I actually take the mean of the middle 2 numbers. So if there's an even number of numbers, which in this case there are, I will look at the middle 2, and I will take the mean of that, or in other words, I will take the middle of the 2 middles. So the middle between 95 and 96 is 95.5, halfway between those two. So that becomes my median. Okay, well, the median does a good job of indicating just what it is. It means half the scores were above a 95.5, and that is true. Half of the scores were, these 4 right here are all above 95.5, and half of the scores are below 95.5. So it does a very good job of describing the middle. But when we talk about an average score on this test, when we say our median is 95.5, there's a tendency in our mind to think, well, that means that half the students were above that, so they were kind of in the 95 to 1 or the 96 to 100 range, which they were. And the others were probably below that, so they were kind of in the between 96 and 90. But that's not the case at all. As we see a number of low scores, a couple D's and an F. So once again, median does what it says it does. It tells you where the middle is, but it can give a very odd impression if we have scores that are particularly clumped at one end or the other. And finally, mode. Our mode is 62. That's our most frequent one. But most people would say that's a very poor indication of what we would think of as average. Now, it is true. If I was to draw a score at random, the most likely score that I would draw would be 62. It would be more likely than any of the others because there's 2 62s and only one of everything else. But we really don't think of that as being a very normal or ordinary score when we have over half the class getting A's and we say that the average is a D. That really does seem a little bit odd. But it is the most frequently occurring score, and it is the one that I would be most likely to pick. Well, strengths and weaknesses of each of these. The mean is obviously can be thrown off by particularly high and low results because every result factors in. And when you divide, things that are particularly high can really pull it up, or things that are particularly low can kind of pull it down. So mean is susceptible to pulling one way or another by particularly high and particularly low. So for instance, even though we've got 5 people that have scored A's, the mean is significantly pulled down by the very low 17 that's there. And so it kind of has been pulled to the low side. The median is not susceptible to that pulling. That's why it's very high. But it also does not take into account if there's particularly high and low, which sometimes we do want to get that picture because the median makes it sound like everybody's getting A's or at least high B's and above, and they're really not. And the mode, once again, the mode can be very good usually if there's a lot of results clumped together. So the mode can be very good measure. If, like, for instance, you're looking for what you would maybe call the average age of students in a class and they're all right around the same age, mode can maybe be good in that sense. But in this case, it's pretty weak. All right, another concept you need to be aware of is the weighted mean. So with the weighted mean, what this is when we assign varying weights to different values. So for instance, this is the type of thing where maybe a teacher says, well, this test is worth a certain amount, this test is worth more, and this test is even worth more. So for instance, if we look at an example of a weighted mean would be something like this, where for instance, we give different, if we look at number 13, if we look at number 13 as an example in your book, which I suppose I do need to open up my book. What we see there is I've set up the problem there to represent it there in the notes, but I want to look at exactly what they're saying, our weighting is. So we have a frequency there, which is telling how many times each of these values is occurring. So there's 4 values of 16. There's only 1 of 18. There's 2 of 20. So we have to add up all of these, but then we have to add up because there were 4 16s, we divide by 4, not just because 16 was entered once. It was actually multiplied by 4. So we have to do that whole tally like that. And so we get a weighted mean of 23.5 when we do that. So you do have to understand that concept and be able to calculate a weighted mean. All right, our next thing, we have a 5-number summary. So this is something that you should be able to do with a calculator, but also do it without a calculator. And mostly we will do it with a calculator when we do a 5-number summary. So in a 5-number summary, we look at a set of data and we list this. We list its minimum, its number, which is called the Q1, which is like its median of the lower half. We list the median. We list the Q3, which is like quarter 3. It is basically like the median of the upper half. And then we list the maximum. So we can summarize that in 5 numbers. Well, let's look at how we will do that for our sample test scores here. So when we go to do a 5-number summary there, what we're going to see is we're going to do this in our calculator. So let's go ahead and let's do a statistical analysis here with our calculator. So I'm going to turn off one of these lights so it doesn't reflect so bad. And I'm going to use these numbers that are right here. So what I'm going to do after turning on my calculator is I'm going to go ahead and I'm going to hit menu. And what I'm doing is statistics. So I will pick choice 6. And then I will do that very first one, stat calculations. I'll hit enter. And this is one variable statistics. So I'll hit enter right there and pick the first one. And this will be the number of lists, which is just one list. And I'll say okay. And now it's going to give me my list. And now here's where it's important. You have to use, when you go to list these numbers, you have to do them with the curly brackets like this, which are found by hitting Control and the right parenthesis. And so now I get those brackets. Now I'll list those numbers. You do not have to list them in order. The nice thing is the calculator will order them for you. So if you have a list that's not in order, you don't have to try to order them. You can just list them in any order. But since I do have them in order there, I'm going to go 98, comma, oops, I didn't go in the correct order. 99, comma, 97, comma, 96, comma, 95, comma, and I'll keep going out of order. So I'll go 17, comma, 62, comma, 62. So I have put them in. They're not necessarily in order. And now I'll go down here and I'll click OK. And now I get the following statistical information in your calculator. So if you want to scroll up, notice what you've got. First, I have this X bar. That is the mean. So if I go here and I see that X bar, that's the mean. Notice I have some other measurements. We'll talk about them in a second. But notice here's the numbers for my 5-number summary. The minimum of X is 17. The Q1 is 62. You can see that. The median is 95.5. We already found that. The Q3 is 97.5 and the max is 99. So that's my 5-number summary. So when we look at that information, we see the X bar is the mean. We see the range is between the max to the min. When we talk about range, that's the max minus the min. The IQR, which is listed, which is sometimes asked for, is Q3. It's called the interquartile range. It's Q3 minus Q1. That sigma that we saw there, that's one of those things, the sigma. If I was to put this back here so you could see the sigma, I was to go back, that would be this right here. That sigma is the standard deviation. In this case, it's the 27.494. And that's if that's if the values are a total population. If it's just a sample, then we use that S for standard deviation there that was right above it. Normally, we will always use this one. So for our test example there, what we get is we get that for our 5-number summary. 17 was our min, 62 was our Q1, 95.5 was our median, 97.5 is our Q3, and 99 is our maximum. If we do a box and whisker plot for this, our box and whisker plot would look like this. What we do is we make a box for our IQR. So we make a box with our Q1 to our Q3, which is the 97.5. We put our median in the box where it fits proportionally. In this case, it's 95.5. It's right up near 97.5. And then we make whiskers going out to the max and a whisker going out to the minimum. And that's what our box and whisker plot looks like. Now, before we talked about outliers, and I said it's basically just your judgment whether it seems particularly high or particularly low. Now we will actually give, since we're looking at this numerically, we will actually give a defined definition of what it means to be an outlier. So an outlier is defined to be any result that is greater than 1.5 times the IQR below Q1 or above Q3. So basically, I figure out what this IQR is, this distance here. I multiply it by 1.5, and then I subtract from here to see if anything is below that, and I add to here to see if anything is above that. Those would be outliers. So the IQR, in this case, would be 97.5 minus 62, so it would be 35.5. I would multiply 1.5 times that, 53.25. So in order to be an outlier, it would have to be 53.25 less than 62. Obviously, 17 is not, so there's no outliers in this case. So in this case, there are no outliers. If there was a number that was less than 8.75, it would be an outlier. Obviously, there's no room for outliers above. So the last thing we're going to look at is normal or Gaussian distribution. So when things are normally distributed, that means that it follows this formula right here for normal distribution. That's the formula. In other words, that's our classic bell curve. So this is what things look like. And you can pause the video and sketch this if you want to. But this is what the results look like in normal or Gaussian distribution. And what we see happening here is all this information here. So we get our bell curve. The middle of the bell curve is the mean, wherever the mean is. When I go a standard deviation or a sigma in that direction and a sigma in that direction, within one standard deviation, sigma in each direction, 68% of the results approximately fall. If I go out to 2 standard deviations, 95% of the results fall. So that means there's just 2.5% below 2 standard deviations away from the mean and 2.5% above 2 standard deviations. So we can see that all listed there. If you go out to 3 standard deviations, you actually get 99.7% of the results. Very little is beyond 3 standard deviations. Okay, with that, there's your homework assignment. So it's 10.3 there, 2 through 16, 28 through 30, and 34 through 36 evens, and then the 43 through 45 all. And pretty much you can feel free to use your calculator on any of this. Pretty much all the statistic stuff you will be able to use your calculator on. Okay, with that, hope it goes well. And we do have a Zoom session today at 12:45. If you've got questions about this stuff, I know this stuff can be kind of challenging. So join us for Zoom if you have questions.